Welcome back, everyone. Today we will be learning about proving that a set of points form a parallelogram. This time we are looking at these in the coordinate plane. So let me go over each of the properties or ways to tell whether a quadrilateral is a parallelogram, and we will see how can we do this in the coordinate plane. So first we have both pairs of opposite sides are parallel. In order to check this in the coordinate plane, you would use slope formula to see if the slopes of the opposite sides are equal. Remember, equal slopes means parallel lines. Here's the formula for slope if you forget. Remember that these have to be in a specific order. Next, we have both pairs of opposite sides are congruent. In order to check this on the coordinate plane, you could use distance formula, which I've reminded you of here. This time the order does not matter. Most times I like to put the greater number first, so I end up with a positive, but it doesn't matter what order you put it in. Next we could check if the diagonals bisect each other. On the coordinate plane we would use the midpoint formula to see if both diagonals have the same midpoint. And finally, we have one pair of opposite sides is both parallel and congruent. So on one pair of sides, we would use the slope and distance formula to see if they have the same slope, meaning they're parallel, and distance formula to see if they have the same length. Let me show you an example. It says graph quadrilateral KLMN with the vertices given. Determine whether the quadrilateral is a parallelogram. Justify using the slope formula. So if we are trying to justify using the slope formula, we are trying to check if both pairs of opposite sides are parallel. So what we will do is go through each side. So we can start with KL. In order to find slope, we know the formula, but if we have it on a graph, we can also use rise over run. We go up 1 unit over 1, 2, 3, 4, 5, 6 units. So the slope of this is up 1 over 6. Now I would suggest checking the opposite side next to see if these are parallel. Now the slope of MN or NM, you go up 1, you go over 1, 2, 3, 4, 5, 6. So this also has a slope of 1/6, meaning KL is parallel to NM. So far we're on the right track. We have one pair of opposite sides are parallel. Now we will check the other pair. So we'll find the slope of KN by finding the rise over the run. We go up 1, 2, 3, 4, 5, 6 over 1, which could be simplified to 6 if you'd like. Then we will find the slope of ML, same way, rise over run. Again, we get 6 over 1, could be written as 6. Since these have the same slope, it means that these lines are also parallel. So KN is parallel to ML. So we can say quadrilateral KLMN is a parallelogram because both pairs of opposite sides are parallel. Okay, I want you to pause the video and try the 2 practice problems shown on the next page. Here are the correct answers. Next, let's look at finding the missing coordinates. This should remind you of the Desmos activity that we did. It says 4 jets are flying in formation. 3 of the jets are shown in the graph. If 4 jets are located at the vertices of a parallelogram, what are the 3 possible locations of the missing jet? I'd like you to try this one on your own today. Finally, for the reflection question, I want you to do this. Please draw a parallelogram on the coordinate plane provided. Your example needs to be different from any of the others that were already provided. Make sure that it's a parallelogram by checking using one of the theorems that we talked about. that's all I have for coordinate plane parallelograms. Next, we will be looking at the properties of rectangles. Talk to you then.